Welcome to this video on dividing fractions. Let's begin. Before we can learn how to divide fractions, we need to define and understand what is a reciprocal. So you might have heard of the phrase reciprocity in just everyday life, right? If you reciprocate somebody's gesture, it's kind of like you're giving it back to them, right? If they give you a nice gift, then you reciprocate by giving them a gift, okay? So we can kind of take that definition and apply it to, or use it to help us understand what a reciprocal is in math, okay? So reciprocal is specifically going to refer to fractions, okay? And if I have a fraction, let's say it's a over b, where of course b can't be equal to 0 because we're not allowed to divide by 0, right? So if I start it with a over b, then we say that by definition its reciprocal is b over a. Okay, so let's see if we can take this definition and use it and apply it in a few examples. So let's say we want to know what is the reciprocal of 2/3. So again, remember, to find the reciprocal, if we start with something that looks like a over b, it becomes b over a. So if we start with 2/3, then the question is, again, what is the reciprocal of 2/3? Well, it's going to be 3/2. In other words, the denominator 3 becomes the numerator, and the numerator 2 becomes the denominator. We are flipping it. So again, let's relate that back to the just colloquial definition of reciprocity, right? So it's like you're I don't know, kind of flipping somebody's compliment or somebody's gift, you're putting it back on themselves. So if you think about it as flipping, in that case, then it can help you remember that we're flipping a fraction when we find the reciprocal. So things will get a little bit hairy when we have just an integer, right? So 2 is an integer. So how on earth, since there is no denominator right now, right, there's just a number, how could I find the reciprocal of just 2? Well, the answer is that first I have to create my own fraction. So 2 is the same as 2 over 1, right? If I say I ate 2 pizzas, that means that 2 pizzas were divided amongst one person, me. Okay, so again, remember, anytime you multiply or divide by 1, you're not changing the value of whatever you're multiplying or dividing. So 2 over 1 is the same as 2, so now it's easy to flip it, right? 2 over 1 is clearly going to become 1 over 2. So 1/2 is the reciprocal of 2. Okay, and then last question, what is the reciprocal of 0? So again, just 0 is just a number, it doesn't have a denominator, but we can give it a denominator, right? 0 over 1. If I have nothing and I share it with just one person, myself, it's the same as just having nothing. Okay, so when we go to find the reciprocal, right, what's going to happen here? Well, the 1 comes upstairs and the 0 goes downstairs, and this is problematic, right, because we can't divide by 0. So we would say this whole expression is undefined. Okay, so that's the only caveat as we're multiplying or dividing fractions either way, or we're using reciprocals. Be careful about 0. Okay, so now that we've defined the term reciprocal, we can actually start learning how to divide two fractions. So we have 1/2 divided by 1/3. Okay, and the truth is, believe it or not, we don't have a direct method to evaluate this. We have to actually do it indirectly by first converting the division to multiplication. So as you can see here, it says the division a over b divided by c over d is equal to, or equals, the multiplication a over b times d over c. Okay, notice that this guy and this guy are what? They are reciprocals of each other. So that's why we had to define and understand what a reciprocal is, because we're going to be using that to describe the process of dividing fractions. Okay, so you might remember the cute little memory technique. I encouraged you to use it as long as you remember what it applies to. A lot of times people were like, oh, this is the keep, change, flip thing, and it has something that is absolutely nothing to do with dividing fractions. And I'm like, no. So use keep, change, flip. Just remember when it's appropriate to use it. It's only appropriate when you're dividing a fraction by another fraction. You can't use it for anything else. Okay, so again, as you can see here, we're just rewriting it as multiplication, and here is very kind of high level and symbolic, so let's just go ahead and apply it to several problems so it starts making sense. Okay, so when I say keep, change, flip, what on earth am I talking about? Well, when I say keep, what I mean is I want to keep the first fraction. In other words, 1/2 just stays 1/2. Nothing happens to him. Okay? When I say change, what I mean is I'm going to change this division sign to multiplication. Okay? Because by definition, dividing by 1/3 is the same as multiplying by its reciprocal. So when I say flip, what I mean is I'm going to flip or find the reciprocal of the second fraction. Okay, so again, by definition, 1/2 divided by 1/3 is mathematically equivalent to saying 1/2 times 3/1. They mean the same thing. Okay, so once I do that, then we're back with multiplying fractions. Hopefully you watched that video. So 1 times 3 is 3, 2 times 1 is 2. There's no reducing that, so we're done. So the final answer is 3/2, or 3/2. So it's as simple as that. Keep, change, flip. Just make sure you remember what we're talking about when we use those words. Okay. Example 2. So we have 5/3 divided by 9/10. So again, keep. We're going to keep the first fraction, 5/3, just as it is. Nothing happens to him. Okay. We're changing. What are we changing? We're changing the division sign to a multiplication sign. Okay. Then what are we flipping? We're flipping the 9/10, right? We're finding its reciprocal. So it becomes 10/9. So in other words, 5/3 divided by 9/10 is mathematically equivalent to the expression 5/3 times 10/9. Okay, so if you can, you want to try to reduce first. Unfortunately, in this problem, there's nothing to reduce, so we just multiply across. 5 times 10 is 50, 3 times 9 is 27. So that would be your final answer. Again, you cannot reduce that. That's as reduced as it gets. All right, let's do another example. At this point in the video, I want to strongly urge you and encourage you to pause these examples. Try to work them out on your own. If this were a face-to-face class, that's what I would be doing. I would stop teaching. I would ask students to set it up, maybe work with a friend or a partner. See how far you can get the problem. See if you can get all the way to the answer. And that way, what's going to happen is any misunderstandings or misconceptions you have about the concept are going to come to light. Right, because you want to find them now, not at the end when you're taking a test. So here we go. Again, try to do this on your own without me. All right, so we have -6/25. We're keeping him. We're changing the division to multiplication, and we can only do that because we're about to flip that second fraction. So 12/5 is going to be 5/12. So this is equivalent to -6/25 times 5/12. Okay, so unlike our previous examples, this time we actually do have the opportunity to reduce some numbers before we multiply across. So 5 goes into 5 once, 5 goes into 25 5 times. Okay, then 6 goes into -6, -1 time, and 6 goes into 12 twice. Okay, so now we can just multiply across. So we have -1 times 1 is -1, 5 times 2 is 10. Okay, and I don't want to spend a lot of time on this in this particular video because I spent a lot of time on it already when I did my videos on multiplying fractions. But you could absolutely multiply across first. You could do -6 times 5. But then notice you're going to get 25 times 12. That's a pretty big number. In fact, it's 300. Okay, but you could multiply first if you wanted to. And then, of course, you would have to reduce. Both of these numbers are divisible by 30. And so you would still end up with -1/10. Okay, so I am not trying to tell you in this video that you can't use that method. I just feel reducing first makes it a lot faster and simpler. So that is the method I will be demonstrating in these examples. Okay, so if we look at example 4, just take a minute, look at it, right? What's pretty different about it, right? It doesn't really look like the example we just did. It doesn't look like any of these other 3 examples. And the reason is because we're using a different symbol in between our 2 fractions, right? We're using a bar instead of this traditional, instead of the traditional division symbol, okay? However, this is still actually communicating the same thing, just like, in some contexts, a capital A and a lowercase a both communicate the same sound, right? One is just maybe a proper noun or at the beginning of a sentence, right? But it means the same thing. Same thing here, right? If I'm using, this division symbol or that division symbol, I am trying to communicate the same thing. Okay, so this, as it is written, is what's called a complex fraction. Okay, as you can see, a complex fraction has a fraction in its numerator or its denominator, or in this case, both. Okay, so we're still going to do a keep, change, flip. However, what we can do to help ourselves to get back to something that looks like the problems we have been doing is we can rewrite it using the traditional division sign. So let's go ahead and do that. So this says 1/2 divided by 1/3, so I can just rewrite it as 1/2, divided by 1/3. Okay, and you might realize, gee golly, we have already done this problem. This was actually the same as example 1, but that's okay. So we're going to keep the first fraction, that's our 1/2. We're going to change the division sign to multiplication, and we are going to flip 1/3. He's going to become 3/1. So again, mathematically, 1/2 divided by 1/3 is equivalent to 1/2 times 3/1. Again, we would just multiply across, and our final answer is 3/2. Okay, so please don't let these new way of writing fractions scare you. Okay, again, it's just one extra step to rewrite it using the traditional division symbol, and then you proceed as usual. Okay, and again, if it helps you, you can look at this cheat sheet as a reference to help you remember that. Okay, so we have another complex fraction, right? So the first thing I'm going to do is I'm just going to rewrite it so that it looks like our first examples, right? So this is not, as I rewrite it, this is not part of the keep, change, flip, right? I haven't started that process yet, okay? Now that I've rewritten it so it looks like this, now I will keep the 5/7, I will change the division to multiplication, and I will flip the second fraction, okay? So this becomes 5/7 times 14/15. Okay, and again, we have a fraction that can be reduced. 5 goes into 5 once, 5 goes into 15 3 times. Okay, then over here, 7 goes into 7 once, 7 goes into 14 twice. Okay, so we take our reduced numbers. We have 1 times 2, that's 2. 1 times 3 is 3. So my final answer here is 2/3. Again, you could multiply first and then reduce. It's just going to maybe take you a little bit more time. Okay, example 6. So I want to stop here and look at this, right? Because this is even more strange, perhaps, than what we had in examples 4 and 5. Okay, so if you go back to the definition of complex fractions, right? It says that a complex fraction has a fraction in the numerator or denominator or both. So in this case, right, I have a fraction in the numerator. My fraction in the numerator is -7/3, but I don't have a fraction in the denominator. So if I were to rewrite this with that traditional division symbol, I would have maybe -7/3 divided by 14, right? And that's a little bit confusing, right? Because we don't know, how can I apply keep, change, flip if I don't have anything to flip? Well, what we have to do is we have to remember what we first discussed when we were talking about reciprocals. So remember on this slide when I asked you what is the reciprocal of 2, right? To find the reciprocal, I just put 2/1 and then I flipped it. So we're going to do the exact same procedure in this problem. So 14 right now is just an integer, but I can write it as 14/1. 14 divided by 1 is still 14, so I have not changed the value of it. But what I have done is I have made it possible to apply keep, change, flip. So notice I've written here the steps to simplifying complex fractions. So the first thing I did, as you can see, is I converted my integer. I converted 14 to a fraction by writing it as 14/1. Okay, and then the rest of the steps, as you can probably tell, are going to be exactly the same as what we were doing in previous examples. So again, I want to encourage you to, as we go through each example, to pause this video, try to work it out without me, and then unpause it. You can even watch it at double speed if you think you got the right answer, or click through in order to verify your work and make sure you got it correct. Okay, so we have -7/3. We're going to keep him. We're going to change the division sign to multiplication, and 14/1, we're going to flip that, and the reciprocal is 1/14. So now we know how to multiply fractions, right? I can either reduce first, or I can multiply and then reduce. So again, my preferred method is to reduce. So 7 goes into -7, -1 time. Okay, and then 7 goes into 14 twice. So I have -1 times 1, that's -1. 3 times 2 is 6, so my final answer is -6. Again, I could have just multiplied across, that would be -7 over 42, but then to get my final answer, I would have to divide both numerator and denominator by 7. Again, either way, as you can see, I still get -1 over 6. Okay, so to review really quickly, right, the first thing we did is to convert our integers, in this case 14, to a fraction by writing it as 14 over 1. So that's our first step, right? Then, again, we can rewrite the complex fraction as just regular division if desired, and that was step 2. So this is step 1 right here, right? Step 2 is writing it like that. Okay, then we did our keep, change, flip, right? This is step 3, right? And then, of course, if you multiply first, right here, this is step 4, then we would reduce. Okay, again, I reduce first and then multiply it. It's up to you. All right, last example. So once again, you can see that we have an integer and a fraction. So sometimes when I'm teaching this concept, students are like, oh, how do I know it's not 16 over 6 divided by 5, right? How do I know that I shouldn't write 16 over 6 divided by 5? Well, the big tell, if you will, is where the longer division sign is. So can you see how this division symbol is longer, right, than the one between the 6 and the 5? Okay, and that's going to be your big tell. So this longer line is going to transform into this division sign. Okay, so whatever is above this sign, so I'll color these both yellow so that you can see that they're equivalent, right? So whatever is on top is going to go in front of that division symbol, okay? And whatever is below this line here is going to go to the right of it, okay? And again, I mean, if you ever, I don't know, let's say you had something that looked like this. Right? This is very ambiguous. Nobody should ever write it this way. But let's say you had something that looked like that, right? You would just have to ask for clarification because honestly, until someone tells you their intention in the way they wrote it, right? We don't know. We're not really sure. Okay? So, again, look for the longer line. This longer line is going to transform into that division symbol. All right, so let's go through our steps. So our first step is to convert our integers to fractions. As you can see, 16 is an integer, so we need to put it over 1 so that we're looking at a fraction and we can proceed. Okay, so we already rewrote it using the other division symbol. So now all that's left to do is our normal keep, change, flip. So we keep the 16 over 1, we change the division symbol to multiplication, and we flip 6 over 5. The reciprocal of 6 over 5 is 5 over 6. So I'm going to have 16 over 1 times 5 over 6. Again, my personal preference is to reduce first. 2 goes into 16 8 times, 2 goes into 6 3 times. So 8 times 5 is 40, 1 times 3 is 3. Okay, so my final answer is 40 over 3.